2, 1. Howdy, howdy, this is Mr. Potter. One of the things I liked to do when I was a kid is take my dad's scientific calculator and press with the buttons on it. I knew what addition and subtraction was when I was about 6, but I didn't know what much of the other buttons did. And so what I would do is I would just keep pressing a button and see what happens. And I know that the square root of 8 now is 2.828. I didn't know what square root was then. But I did notice that if I kept pressing the square root button, the number got smaller and smaller. But the other thing I noticed is that that value actually kept getting closer and closer to 1. And eventually I keep to this point where no matter how many times I hit the square root button here, this button right here is just not going to do anything to 1. Similarly, I could take any number like 87, and if I hit the cos button over here, meaning cosine, and I keep hitting it over and over and over and over and over and over again, eventually I get to this value here. And so what I notice is that it's basically repetition, 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 and I eventually hit a stopping point. And this idea in computer science is called recursion, the idea that I take the result from a function and plug it into another function. So I want to draw a picture, kind of explain what's happening here. In our mathematics class, we talk about the idea of a function, f of x. And we have values that go into it, and we have values that come out of it. So if I put numbers into this, I'm going to get some number out of it. That's the idea behind a function. And what we're talking about is we're talking about taking the answer that we're getting out of the function and we just put it back into the function. And we are going to repeat until some situation occurs. So in the case of square roots, I'm going to keep repeating until I get the same value out that I put in, namely 1. In the case of cosine, it's that 0.999847742 value, since I'm just hitting the cosine button over and over. And actually that value depends if you're talking about if you're in degree mode or radian mode. I was in radian mode at the time. But I want to keep repeating until something happens. And the situation that I get at the end is called my base case. So I want to keep going until I hit my base case, the case that kind of says, hey, you're done with this procedure, you need to stop. So I want to do a much simpler example of this. So I'm going to start off with the problem, what is 5 times 6? So normally what I would do is if I saw 5 times 6, I would say that that's 6 plus 6 plus 6 plus 6 plus 6. I mean, this is how a 7-year-old of me would do this because I didn't know what multiplication was at the time, but if I had a number 5 times, I know I better add it up. But one of the things that I notice is that this is really 4 times 6. And if I knew what 4 times 6 was, I would just have to add 6 to that result and I would get 5 times 6. So what is 4 times 6? Well, that's 6 plus 3 times 6. Well, what's 3 times 6? This value right here is 6 plus 2 times 6. And 2 times 6 is 6 plus 1 times 6. But this brings up something interesting because 1 times 6 is 6. If I have 6 one time, then it's a 6. And this represents my base case. In other words, what I'm trying to work my way down towards. This is 6. And so if I wanted to figure out what 2 times 6 is, I would just take 6 plus 6, and that gives me 12. So then I would take 12 plus this 6 here, and that would help me get 3 times 6, which is 18. And then I would take that and add 6 to it, and that would give me 24. And then I take that 24 and add it to 6, and that gives me 30. And that means that 5 times 6 must be 30. So the idea of recursion is that we're going to repeat a task over and over again until we hit a base case. In the case I just did, we could think of multiplication as repeated addition. In the case of square roots, I'm taking the square root of a number over and over and over and over again until I reach the same value. In our turtles and in our Python, we're going to be performing the same action but with smaller and smaller values until we reach a situation where it doesn't move the pixel at all. So I can imagine a situation where I want to move 40 pixels, then move 30 pixels, then move 20 pixels, then move 10 pixels. And then when I try and move 0 pixels, well, that's no movement at all. And so I can imagine a spiral like this, where I'm moving a certain amount each time. How do I move? Well, I move 10 less than I moved last time. And I keep doing this as long as I haven't reached this base case yet. And so in order to understand this base case, I have to understand the idea of a conditional statement. In other words, this word, if. If something happens, then I do something. Or if something happens, I don't do something. And so that's what we're going to be headed with the next weeks of video lectures. So once again, this is Mr. Potter. Thank you for watching. Have a great day.